All right, everyone. Very good morning, very good evening. Right, so this is going to be one of the uh, first demo session for our new batch that's on Oracle 19C RAC administration workshop. Uh, today and tomorrow are going to be two demo classes um, where I'm gonna cover about some of the basics of this RAC and then understanding of RAC and Oracle database comparison. Yeah, I'll keep it simple today and tomorrow, uh, and then I'm going to explain about course curriculum and course timings and course details and other uh, you know other details whatever related to this course. I'm not going to cover any advanced topics in today and tomorrow session because these are like just demo classes. I want everyone to be clarify or everyone to be ask your questions and doubts and then uh, clarify all your queries or concerns. Uh, Having said that, starting with the introduction about myself, I am having around 13 to 14 years of experience in this IT industry. Uh, Entire this 14 years, I worked as a Oracle DBA, RAC expert, and data guard expert, Golden Gate expert, and Exadata administration expert, and um, in fact, like this entire 14 years, my journey started with Oracle DBA, and then I am till this entire 14 years, I'm into this Oracle world. So apart from this Oracle world, I do have other, expertise in MS SQL, PostgreSQL, Informatica admin, and Erwin data modeling, so many other product and other certification I hold, but still, if somebody asked what is your primary domain, Oracle is my primary domain. Since I started my career with Oracle as a Oracle DBA, and then uh, I don't want to go out of this Oracle world. So I took it as a challenge, and then I learned almost all the product offered by Oracle. I started with Oracle DBA, and then I learned RAC and I become RAC expert. I learned Data Guard, Golden Gate. I become Golden Gate expert. I learned Oracle engineering system, right? Engineering systems are your Exadata, Supercluster, and Exalogic. All these engineering product I learned and I certified with that. And I worked with Oracle on the engineering systems, and also I worked on Oracle EBS, Apps DBA. I worked as Oracle OBI application support, Oracle uh, SOA, and Oracle PeopleSoft. And then after that, I started my cloud journey. I learned Oracle OCI, and I learned Oracle Autonomous Database, and also I worked couple of years as a infrastructure admin, especially for Oracle Cloud. Having said that, my journey started with Oracle, and then I was stick to this Oracle. Many people will often tell that uh, cloud is coming and so many other technologies, DevOps and all. Uh, is there any impact on the DBA job, right? So absolutely no, there won't be any impact because Oracle is evergreen. So most of the enterprise customer, Oracle is going to be backbone for them. Small customer who are like startups and all, they won't bear the charge and license cost for Oracle. They will start with the small open source databases like Postgres and MongoDBs and all those things. And once they become enterprise customer, security and data and cyber threats are going to be major concern, and they definitely going to switch to Oracle database. So because of that, Oracle is so powerful in database domain and in security and in enterprise support. So Oracle is going to be backbone for most of the customer. So being as a Oracle DBA, it's going to be one of the advantages, and Oracle DBA is going to be evergreen. And having said that, but it is at the same time learning other technology is going to be added advantages, right? You are gonna go ahead and learn your DevOps skills. So even for me, I learned so many DevOps skills. I'm good at Terraform scripting. I'm good at Ansible scripting. I'm good at AWS scripting, right? So these are going to be added advantages for a DBA based upon your work need or work role. If you're working for one of the client, if they're having AWS, and then go ahead and learn AWS orchestration. So you can do a lot of your DBA jobs or DBA task automation, right? So those are like DevOps skills, but learning them is going to be one of the added advantages, right? So that's about my overall experience, like, entire this 14 years of IT experience. I am stick to this Oracle world, and I'm doing great in this Oracle world. So that mean like I am ready to take any challenge, especially in Oracle world, like any new job, any new technologies, anything new in Oracle, I'm ready to learn and ready to expand my skills. That's how my nature is. I'm always willing to learn. So learning is like never ending story. So always you have to enhance your skill. Then only you will be up to date in the market and in this competition world. If you learn and enhance your skill, that's going to be one of the added advantages. And you can easily get a new job, or you can easily crack any interview and all. So that's my that's my always request to all my students. Always keep learning your skills and keep enhancing your skills and keep upgrading your existing knowledge, right? Oracle also keep on releasing the new products, right? New versions, and then the moment they release the new version, it is our DBA job to go ahead and learn it and deep dive into that and need to understand what is new feature in that. Right now 23C is the one, like, come with a lot of new things and new technologies. With that we can go ahead and then expand, and we can go ahead and then check it out what all new coming in that and all those things. Right, so that's about me and then my overall experience with this IT journey. And then coming back to this course, I'm gonna call this as a Oracle RAC administration workshop, because whatever I'm gonna teach is going to be purely a real-time experience and purely a live demonstration. I'm not gonna cover any theoretical part. I'll just leave it to you guys to read and then understand. But what I'm interested is I want everything to be shown in a live demo, each and every topic. And along with me, I would request everyone to carry the lab exercise and then perform hands-on experience. So that once you do hands-on experience, that will be like more than reading 10 times. If you read 10 times, 20 times, you can easily forget it. But once you do a hands-on lab exercise by your own, and you'll never forget. And at any time you just somebody asks the question, you can easily remember once you do a hands-on. So always I request everyone, like, do a practice, then only you'll remember. If you read, you will forget easily, right? So that's how I always used to call my courses as a workshop rather than training or a session, because I wanted to show it as a live demo based upon my real-time experience. Right. So meantime, if anyone has any questions or queries, feel free to raise your hand or unmute yourself and uh, ask any questions. And also you can post your questions in the chat box here. Right. I'm just going to quickly cover about this course curriculum, and then followed by I'm going to start with some of the RAC concept for today. Right. So we will start with the chapter number 1, that is the introduction to clusterware, how this RAC stands for real application cluster, and what exactly mean by cluster, how the database we're going to cluster it, combine together with the multiple servers, we're going to make it as a RAC, where we can compare with standalone versus RAC, and we'll understand the networking need in order to form a cluster. That's your introduction part, and then followed by we're going to go with the my Clusterware architecture, RAC architecture, how it's going to works, your OCR routing disk, and how you're going to startup sequence works in Clusterware. We'll start with that architecture part, and followed by your chapter number 3, 4, 5 are all going to be your entire cluster setup, We'll start with the Linux understanding first. We'll cover the basics of Linux, and in that we're gonna cover some of the networking and shared disk and your public IPs, your virtual IPs, your scan IPs, and your VIPs. All the networking we're going to cover along with some of the basics of Linux, because those are pretty mandatory for any rack expert or rack DBA. Knowing Linux and networking is mandatory things. So we're going to cover all those things, and followed by we're going to start with the cluster installation. We're going to install 2-node cluster setup, 2-node grid setup, and followed by we're going to install 2-node rack database, and we're going to install rack Oracle Home first, and followed by rack database. So we're going to create some of the shared disk groups with the help of that shared disk. We're going to create data, RICO, FRA, and OCR, all those disk group we're going to create, and then we'll create a database. Right. So this all like very basics and very mandatory stuff for DBS, because this is going to take almost like 10 to 15 hours. This entire rack setup, if you start it from the scratch, it'll pretty much it's going to take around 15 hours, because you need to understand each and every concept when you're building your 2-node rack. That is going to be one of the major tasks. Once you are able to do this cluster setup by your own, that will give you more confident, like more understanding in this particular rack domain, because like it is not easy to form a shared disk. It's not easy to understand your public IP, VIP, scan IP, and all those things. And without understanding them, you'll not be able to proceed further with the rack setup. Once you're able to understand all these basic concepts, shared disk and your networking concept and your ASM libraries and your ASM disk groups, once you are able to understand, able to get hold of this one, and learning further uh, rack administration tasks are like very simple. So this is going to be very challenging and very interesting. So uh, everything will be like covered from the scratch once you do your hands-on installation, and that will give you more confident in this learning journey, right? And then followed by we are going to start with the ASM architecture, right? So ASM architecture is going to be very basic need for rack. Without ASM, we will not be able to achieve your rack database or rack clusterware. So we're going to start with understanding of ASM architecture, and followed by ASM administration, like all the ASM storage component, how your ASM storage disk group is going to work, how your data files are going to store inside your disk group. All those things we'll understand, followed by some of the features of ASM, like mirroring, striping, and all those things. And what are your ASM parameters and your ASM administration, like adding a disk group or creating a new disk group or dropping a disk group, or when your disk group is exhausted, space is full, how you're going to add a new disk to existing disk groups. All those things we're going to cover here as a part of this RAC course. And then administration of your ASM disk group, again, same thing, adding, removing disk and disk rebalancing, data rebalancing, and mirroring, striping. All this will be covered over here. And followed by your rack database administration and clusterware administration, like your CRS-CTL versus SRU-CTL. Many DBAs so far, they will be confused when to use SRU-CTL, when to use CRS-CTL, and then which command will be run with a grid user, which command will be run with a root user. So many things here. We're gonna keep it simple, like what scenario and what situation you're gonna use SRFCTL, and what scenario you're gonna use CRSCTL, and when you're gonna run this command with the root user, when you're gonna run this command with the grid user or the Oracle user. Those are basic understanding. Once you get to know those basic understanding, you can easily manage your cluster. These are very important. We always deal with CRSCTL and SRCTL. When you're working on clusterware, we always deal with the CRSCTL and SRCTL. And followed by restarting your databases, services, and your cluster node reboots, and all those things will be covered here, right? And then followed by your core component of your clusterware. Core component of clusterwares are what? Like your OCR, your routing disk, and your OLR and cluster resources, and your VIPs, scan IPs, and public IPs. These are going to be core resources for my clusterware. Without these or without any of them, you will not be able to run your clusterware. So we're going to understand deep dive into that clusterware concept, and each of them we're going to administrate all these component, all these services. Right, and then followed by understanding of your RAC database. How exactly RAC database is different from my standalone database. How my SP file parameters are different from my standalone database. Right, and then how can I create a P file and SP file for my RAC database, and how I can create my password file for my RAC database, and where I'm going to store this password file system or disk group or where, right? And then redo log, how redo log control files, data files, and table space, undo files, and temp files, how they are different from my standalone database. Is that I'm going to keep it for instance specific or database specific, and where I'm going to keep them. I'm going to keep them in ASM disk group or local file system. Each of them, we're going to deep dive on that. And then followed by your RAC database restores and recoveries. We're going to understand first backups. Once we're able to take a successful backups, level 0, level 1, arclog backup, control file backup, SP file backup, and with help of those backups, and you're going to do this restore recoveries of various components, restore of a data file, restore of SP file, restore of your control file, and restore of your entire database. And then once you understood about restore and recover scenario, and you're going to go with the RMAN cloning, how you can clone your RAC database from one cluster to other cluster, or from one cluster to standalone database, or from standalone database to RAC cluster. So all those cloning mechanism will be explained in this chapter number 14. And then followed by listener. Very, very interesting, because many people will get confused with the listener concept, right? So when it comes to RAC, there are so many listeners. You can deal with ASM listener, and you can deal with the scan listener, and you can deal with the database listener, and followed by some remote listener, we can call it, or some local listener, we can call it. And there are some ASM net listener and some ASM management listener. So hardly, like I can say, around 6 to 7 listeners you will deal with. And then all of these listeners importance when we need to use these listeners, right? So we're going to understand all of these listener concept here in this chapter number 15. And chapter number 16, again, purely a RAC multi-tenant architecture. We're going to understand first multi-tenant architecture, and followed by we'll understand the CDBs and PDBs, and followed by how you're going to clone your PDBs, how you're going to take a backup of your PDBs, how you're going to restore your PDBs and CDBs, and connecting to your CDBs versus connecting to your PDBs with the sys user, or with the password authentication, or with the OS authentication, and cloning of your PDBs, different mechanism of cloning of PDBs, and creating a PDB. All those things will be like covered or explored here in this particular multi-tenant architecture. Again, believe me, multi-tenant architecture is going to be future from Oracle. So in 11G, it's just like a normal database, and in 12C, they came up with this multi-tenant architecture. Like that will be your CDB or like PDB, right? So this is your CDB or PDB they came up with in 12C. And in 19C, while creating your database, you can create a database as a normal DB, or you can create it as a CDB, right? You have option normal DB or CDB in 19C. But in 21C onwards, there is no more normal DBs. Whatever database you're going to create, it will be like CDBs. And inside that, you can create a number of PDBs. 21C onwards, it's everything going to be CDB. There's no normal DB concept in 21C onwards, right? So multi-tenant architecture is going to be one of the key, and all the DBAs, irrespective of whether it's a RAC or standalone or whatever it is, you have to understand, you have to learn your multi-tenant architecture, you have to learn your CDBs and PDBs concept, because 21C onwards, there is no normal database. Right, so that's your chapter number 16, and followed by we're going to understand ACFS. We're going to configure ACFS, and we'll administrate the ACFS. very brilliant feature with Oracle ACFS. We can call it as ASM cluster file system. So very interesting one. So many people, many of my friend circle, if I ask them what is ACFS, have you used ACFS? Many people will say no. But if you understand about ACFS and you literally love it, and why I'm telling that one, ACFS will give something called snapshot feature. So what exactly the snapshot feature? And if you create your database into ACFS, assume that your database is of 50 terabyte, right? Your database is a 50 terabyte, and you want to clone this database, your 50 terabyte database, you want to clone it to, this is your prod DB. Prod database is on ACFS, and which is a 50 terabyte, and you want to clone this database to DevDB. And believe me, you just take a snapshot of this 50 terabyte, and your DevDB will be ready in 10 minutes. Within 10 minutes, your 50 terabyte production database, you can clone it as a DevDB just by taking a snapshot. Right, so that's going to be one of the brilliant feature. Once you try using it, and it'll be default with your rack. The moment you install your rack, so ACFS default comes with that. So once you start using that ACFS and you love that, and you will gonna start suggesting to most of your customers. And then we'll start with the understanding of RAC-1 node. What's the difference between RAC database, RAC-1 node database? Special kind of database, RAC-1 node. There's a separate need and use cases for RAC-1 node. We're gonna talk about that RAC-1 node, and you're gonna relocate, how you're gonna relocate from one server to other server. We're gonna see this one. And followed by, we're gonna deep dive into RAC clusterware patching, very important. As we all know, Oracle will release patches on every quarterly basis, right? So if I can brief it, Oracle will release patches on Jan and July, October, and Jan, April, and July, and then October. So these are the 3 quarterly patches. Oracle will release every year, 4 times they will release PSU. And as a DBA, we need to apply these patches on regularly. And when you come to RAC database or clusterware patching, there's something called rolling patching and non-rolling patching. Rolling patching, it's a completely online patching, no downtime at all. Non-rolling patching, it's a complete downtime. How you're gonna do that patching with rolling and non-rolling? Common question in most of the interview: what is rolling patching? What is non-rolling patching? What are the best practices for patching? And how I can minimize the downtime for the patching? And then what are the pre-checks? What are the post-checks for the patching? All those will be like covered here, like, patching your clusterware, patching your Oracle home, patching your database, and finally running your data patch. And you have OPatch and OPatch auto. Again, common questions: what is OPatch and what is OPatch auto? So all will be like discussed here as part of patching, right? And then upgradation. So upgradation is going to be again one of the critical and major activities for a DBS. So as far as I know, we can do this database upgrade using manual method and GUI method. So GUI method is your DBUA, database upgrade assistant. We're going to run this one, and we're going to do DBUA. And in manual method, running your there's a cat upgrade script. Cat upgrade script one way you're going to do using cat upgrade script. And second one is you have something called Perl script. And third is you have something called shell script, that is your DB upgrade. So in manual method, you can do either running cat upgrade script, or by running Perl script, or by running shell script. These are the 3 methods to do this manual database upgrade from 11G to 19C, or from 12C to 19C, or from 12C to 21C. Like any other, like if you want to do a database upgrade, either you can go with the manual method or GUI method. GUI method is just a DBUA. You're going to run this one. In manual method, you have three options: run the cat upgrade script, or run your Perl script, Perl upgrade script, or run your shell upgrade script, DB upgrade script. And in 19C, we have some auto upgrade, right? Auto upgrade is a new feature, came in 19C. You can use this auto upgrade, brilliant feature. I did hundreds of database using this auto upgrade. And in this auto upgrade, you have a lot of automation tasks. You can schedule a job, okay? You can schedule your database upgrade in midnight and you can go back home and you can sleep around, say, right? So this auto upgrade, you can schedule one database after one database, or you can schedule your database upgrade parallelly. A lot of things, and you can monitor with this database upgrade using this auto upgrade tool. Auto upgrade tool came in 19C, and you can do a lot of automation for your database upgrades. So this came in 19C. So combining all together, you can have around 5 methods of database upgrade: DBUA, auto upgrade, your cat upgrade, Perl script, or shell script. You can use any one of method and you can do this upgrade. So we'll be covering all these methods, and we'll be like doing examples with each of these methods, and we'll see how the database upgrade goes. Right. That's about your database upgrades, and followed by node addition and node removal. So very, very interesting concept. Like right now you have a two node cluster, right? Your node 1 and node 2. Your database instance 1 is running here, your instance 2 is running here, and this is your cluster setup, two node cluster. And if you want to add a new node, like your business is growing, you want to add it new node to this cluster. That's your node addition. And again, business is growing, you want to add one more node to your cluster. You can add one more node. It become node 3 and it become node 4, right? So that's your node addition without impacting uh, how you're gonna add these nodes. And once you add the node and later you want to remove this node, for example, like right now you added two more nodes, and later after certain days you want to remove this node, right? So you can go ahead and remove this node from your cluster without impacting anything on the existing databases, right? That will be covered here: node addition and node removal. And converting your single instance, like you have a standalone database or single instance, you want to convert it to RAC database. So what are the various methods to convert that one? We'll be covering the DBCA or your EM enterprise manager or RAC config, that's R config. So all will be like used, and we're going to show another demo here. And at the end of, okay, so certain things are not mentioned here, but that will be part of your course. For example, your OCR corrupted, your OLR corrupted, and your voting disk is corrupted. Right? We talked about here, right? Core component of your Clusterware. Where is that one? Okay, here. Your core component of your Clusterware, your OCR voting disk, your Clusterware resource. So when your OCR, how you're going to take a backup, OLR, how you're going to take a backup, and your voting disk, how you're going to take a backup. And when these core files are corrupted, how you're going to restore them from the backup. So those will be part of your administration, will be covered over there. And also, if your node reboots, like you have a two node rack, right? Two node cluster setup. And if this particular node is got evicted, and node is rebooted from your Clusterware, and what is the reason for that one? Is this OCR not able to access, or is this OLR is not able to access? Are there any voting disk is corrupted when this node is rebooted, right? So these are core component. If anything happens in your Clusterware, these are the one responsible for that. So we'll be dealing with this core component, and we'll be making sure that how we're going to preserve them by taking a regular backup. And in case of any corruption, how we're going to restore them back. So all will be covered as part of this course, but those steps will not be mentioned here, but it will be part of your course. Right. With that, at the end of the course, we'll be covering with the resume writing and cover letter, and followed by on each and every topic we'll be covering some interview questions and answer. And at the end of the course also, I'll be sharing couple of questions and answers overall, so you can prepare over there. And then will be conducting mock interview. Again, it is this is like not mandatory. It is left to the respective who are interested can register, and we can have a mock interview one-on-one. So that you can understand whether you prepared for the interview or not. Right, that's pretty much about the course content or curriculum. Anyone has any questions on the course curriculum or any questions? I can see two questions here. Flex will be covered or not? So Flex will be architecture will be explained, but default Flex will be part of your 19C. The moment you install your 19C clusterware, Flex will be default installed on that. You no need to install it separately. It's part of your clusterware in 19C. SFS will be covered, and your fan, TAF, all will be covered here as part of this course. And startup shutdowns issues, yeah, everything will be covered because it's a part of course. And then OCR, OLR, look at, yeah, again, as I said, will be covered OCR and OLR, how we're going to take a backup, how we're going to restore it, and how we're going to relocate from one disk group to other disk group. Yeah, these will be part of your admin activities here. Node rebooting, yeah, node rebuilding. Node rebuilding, again, that will be part of this course. As I said, node addition or node removal, that will be part of your node rebuilding. Adding node or removal will be covered here, right? Again, how about lab? Yeah, lab will be using VirtualBox. We'll be using VirtualBox, and in that we'll be building 2-node rack, 3-node rack, right? And then which certificate? Okay, certificate again will be covered at the end of this course. What certificate you're going to provide? What certificate you are going to? What examination you are going to provide? What examination you are going to appear for this Oracle? You can go ahead and then appear for that exam, and then you can clear it. Right. So that's about the course curriculum. And coming back to the course timings, the course details. This is going to be weekend batch only on Saturday and Sunday, meaning that this 22nd Saturday and Sunday, 22nd and 23rd, these two are demo classes, and followed by 29, 30 are going to be actual class only Saturday and Sunday. 29 is the one we're going to start the regular class. 29 and 30 one weekend, followed by 5 and 6. That will be your November 5 and 6, and followed by 12 and 13. That this weekend, 12th weekend, and followed by this 19 and 20, November 19 and 20, and then followed by 26 and 27 November, and December 3rd and 4th. Hopefully December 3rd and 4th we'll be able to complete. If not, then we're going to take one more weekend. That will be December 10th and 11th. So that's overall planned for this particular course. Again, this is all weekend batches, weekend classes, and it will be like 4 hours on each day, 4 hours on Saturday and 4 hours on Sunday. That will be 8 AM IST to 12 AM IST, 4 hours on Saturday and 4 hours on Sunday each weekend, right? So we're going to typically complete it by 6 weekends. If not, then we're going to extend it by one more weekend. It's going to be 7 weekends, right? And then that's about course timing, course duration, and coming to the course fees, it will be like 15K INR. The course payment can be done with a various method. You can make using UPI, Google Pay, Phone Pay, or you can do a bank transfer, or you can do a Western Union, or you can do a MoneyGram, or various payment method. You can feel free to ping me on my WhatsApp number, or you can call me on my number, 98806168848, or you can ping me on my WhatsApp, or send me an email. I can guide you for the further payment process. Right. So this is about course curriculum, or the course content, or the course details. Any questions before I start with the some of the basics of RAC?
Hi, Malik.
Yep.
This is Sada. You remember I have spoken to you few days back.
Yeah.
Yeah. The question is, would you provide the machine to practice?
Yeah, that's correct. So I'm coming to that point. Like if I can, once you register for this course, once you make a payment, and you will get access on our Google Drive. Typically, your Google Drive, you'll get access on this one. Uh, in that, you have all the materials, and all the material in the sense, you have at entire course. We're gonna follow this single PPT, and the single PPT has all the lab exercise and all the course materials, and everything will be covered from this particular PPT. And this PPT will be available here in this course material, right? Like all the course PPTs, course labs, and all the uh, details, whatever needed, it will be available in this particular course, the Google Drive. And in the same Google Drive, you have this ready VM for your rack. So if you go here, you have your just lab, Oracle Lab 1, Oracle Lab 2, Oracle Lab 3. And then if you see this one, it's a 2-node 12C rack setup with ASM with the Oracle user. And if you have a 2-node 19C rack setup with the ASM user, ASM installation with the grid user. And you have 19C rack setup with ASM and database with the grid user and Oracle user. And if you have 19C uh, rack setup, only ASM and database with Oracle user. So these are like ready labs which are built in available for you. You just need to download it and just need to unzip and just need to configure it in your virtual box. So these are like ready labs when and where needed. When we talk about upgradation, we're going to use this 12C lab and we'll upgrade it from 12C to 19C. When we're working on 19C, we're going to directly download these ready labs and we'll use them. Again, these are ready labs. You can readily download it and use them. But as part of this course, very first thing what we do, we will do this rack clusterware setup. Right? That's important. First, you need to understand and you will be thorough with that setup or configuration by your own. Once you're able to do that, and later you can easily use these ready labs. Right? There are various ready labs. These are all like 2-node labs. Right. With that, one of the prerequisites is you should have minimum of 16 GB RAM in your laptop or desktop. Wherever you're downloading and using it, you need minimum 16 GB RAM in your laptop and then 100 GB hard disk. So these are the two minimum requirement you should have it in your laptop. 16 GB RAM and you should be having 100 GB RAM, 100 GB hard disk in your laptop. If you are having these two minimum requirement, then you can easily use these labs.
I got it.
All right. That's
Good morning. Good
mhm.
morning, Malik. I have
Yep.
one question. Do you accept PayPal payments?
PayPal, no. PayPal, no. Yeah, you can ping me on my WhatsApp. I can share you the for the other details for the payments.
Oh, okay.
All right. Right. So these are labs, and there are a lot of course materials in this particular lab. Like right, if I can go to my PPT here, right. So if I start with this presentation, like each and the single presentation is your single point of contact. When you're reading this PPT and the associated labs are like just attached to that PPT. You just need to open that one and you just need to run with that lab, right? So these are your lab, right? Just attached to that PPT. You just need to refer the single PPT that will guide you. And if you want more lab exercise, we have more lab exercise here. Like if you can go to this lab exercise and we have some more extra lab exercise here. I'll be uploading more exercise here. You can refer them. But otherwise, the PPT is more than enough. You just refer this PPT and all the labs will be associated to that single PPT itself, right? You can go here, user creation and group creation. When you're trying with installation, user creation, group creation, everything will be like attached here. And then when you run with or you want to do run Cliffy pre-check, what command you need to run. And when you go with the passwordless SSH connection, what command you need to run it. So all the labs will be attached to this PPT, or you can go ahead and do the lab exercise from this course material here. Right, and then there are various RMAN, like each and every GI upgrade. There's a special topic, special PPT. We're going to refer it when we deal with the upgradation or the backups and recoveries, and when we talk about patching, when we talk about DR. So we're going to use some more advanced slides and then some more advanced information from this. That's about your course materials, how we're going to look here. And then um, once every day, like recordings will be like uploaded, right? So the moment I cover today's topic, everyday sessions will be recorded and then uploaded here along with the lab material and lab exercises. I'm just going to show you one um, previous batch recordings. And if you want, like you'll be getting access on those previous batch recordings. You can just go through them. Like if I can show you here, like this is how it gonna work. Like every day, like day 5, the recording sessions will be uploaded. On the day 5, whatever the demo I showed, all the commands, right? Whatever command I ran it on my lab, everything will be like captured. Everything will be like uploaded here on the lab. Like you can see, this is my login session, and whatever command I'm running here, everything will be like captured at the end of the session, and then along with the video will be uploaded here. When you're watching that video again, and you can side by side, you open uh, this notepad, and then you can also try and execute the same command when you're watching the video again, right? So that's how each and every lab, like for example day 6 and respective uh, the lab whatever I was like running on my lab. And if I can go further, day 12 and whatever the respective lab for that, right? PDBs and CDBs. Like you can see, this is my session and then what command I'm running. So that it will be so easy that you can uh, whatever you're gonna watch that video again, you can same time you can copy the command and you can run it. You no need to type the command entirely for the practice purpose. Right. So all those videos will be uploaded here on the regularly. And then there's a one more folder. You will be getting access on all these 3, like course material, where you can see your ready labs along with the PPTs and the lab exercise and other information, and the daily recordings. Every day's recording will be uploaded here, and already uploaded some of the prerequisite sessions, like 6 sessions. These are like uh, basics. I want everyone to go through all these 6 videos. These are the prerequisite sessions which will help you for next regular classes. Whenever I'm going to start this regular class on 29th, by the time if you watch these 6 sessions, that will be much more easier on 29th, right? So, and followed by I'll be creating a new folder, and then I'll be uploading all the regular stuffs here. Like I can create a new folder and then daily sessions will be like uploaded here. And coming to this third folder, that will be your all the software whatever needed. Like if I can go to Oracle software here, you can see your 11G software, your 12C software, your 19C software, and all those things, right? So you no need to download it from Oracle delivery. You directly download it from here and then you can use them. And apart from that, there are some other tools for DBAs and some of the monitoring script and some of the ISO images. All those things you can download it from here. You no need to go to Oracle delivery and then download from there. Right, so that's pretty much about course curriculum and course content. And if anyone interested to watch those previous batch recordings, you can feel free to, or else like I'm gonna ping that previous batch recording link in our WhatsApp group, and you can refer them or you can watch them. Again, these are like become duplicate session, right? Whatever we are covering here, the same thing will be covered in our previous batch. So if you, but only thing is there will be a lot of interaction. there will be a lot of questions will be asked by many people, and then we'll be answering. So those questions and all, you will be getting into those videos. If you want, you can go ahead and then watch them if you have a time. Otherwise, everything will be covered here in this particular course. Right. Yeah. Couple of questions here in the chat. We are hoping to do 3 hours a day. Yeah, we can try it out, because if we make it 3 hours a day on weekends, so we may end up with eight weekends or 9 weekends. Yeah, that's why we are making it as a 4 hours. Let's see if everyone are okay, then we can make it 3 hours, not an issue. How many days this PPTs will be having access? So these are like lifetime access, like there is no restriction at all. You can watch it until your lifetime, like there's no restriction at all. And in fact, as I said, there's no restriction at all. Like you can, if you want, you can go ahead and then download them, everything, all the PPTs, all the videos, all the software, whatever you want, like you just go ahead and then right click and download it, no restriction at all. Right. And then anyway, these will be available for lifetime. You can refer it whenever you want. All right. And having said that, we'll be having a dedicated WhatsApp group for each batch who are registered and will be part of that WhatsApp group. And all the communication will happen on that particular group. Any questions, any queries, and all those things will be discussed on that particular group. And that group will be again lifetime accessible. So after the course, you can post any questions and queries in your related to your work environment, and we'll be answering and we'll be getting in touch with those particular issues. And then with that, again, whatever this course you're going to attending, it's going to be one-time registration fees, and you can attend multiple times. And if you are not able to continue this time due to some health issues or due to some certain reasons, and not to worry, you will be having access on the previous batch recordings and ongoing this batch recordings. You can watch them and you can refresh yourself, or you want to attend a live again, you can always welcome for the next batch. Next batch, you can just ping in our group. I'll be anyway posting in our WhatsApp group whenever I'm starting a new batch. So you can feel free to attend that new batch. You don't need to pay any extra money on that, right? It's a one-time registration fees. Right. Right. So any questions, guys, before I start with some of the basics? Right. Let's go ahead and then cover some of the basics. I'll just keep it simple for
Hello.
today. Yep.
Yeah, sir. So the slide you shared, advanced topic, is that part of this course?
Some
Like
of the topic will
security
be
and
covered.
wireless?
Some of the topics will be covered as part of everyone's interest. If anyone interested in any of the advanced topic, for example, your encryption, your wallet, your TDE, and your enterprise OEM, and your golden gate, these are kind of advanced topic. If anyone wants to know basics, I'm happy to take those sessions. But again, that is that is left to everyone's interest. If anyone in our group, like we'll have a voting, like if anyone interested in particular one topic, and we can go ahead and then take those topic as a extra sessions, not part of this course, but will be taken it as an extra session.
Okay.
Right. Let's understand here. I can probably go to my slides only. All right. Okay. Let's go here. Okay. Let's take this as an example here. I'll first cover what is. Do I have any slide for this one? Okay. Let's take it here. I'll just keep it simple for today, and then I can show you demo on that, how the standalone versus rack works. Standalone and rack, if you see this particular slide, this is your standalone database, and this is your standalone instance. So this is your this entire thing, right? This is your Linux server. This is your server, one single server, one single instance, and your database is running on that instance, that server. It's like one-to-one mapping. One database is running on that one server. That's our instance, database instance, like one-to-one mapping. That's called your standalone. And then if anyone, like, this is a three-tier architecture, they will call it in the industry standards, like front end, middle tier, and back end. Or front end, you can call it as a client or web or mobile or presentation layer. Many people will call many words. And this middle tier, they will call it as a middleware, middle tier, Apache or web server or app server. And backend, they will call it as a backend or back database tier, back tier, or data management tier. All these are referred to same thing: front end, middle tier, and back end. These are called three-tier architecture. So any end users connecting via any device, right? They may be connecting with a desktop or mobile application or a web URL or anything, client application. They're connecting to your database, and they all connect to database, the application server. That will be your middle tier, where the business logic runs here. All the connection will go to that application server. From application server, all the connection will go to that particular instance, and from that instance, the connection will go to database. So in case of this server goes down, entire database will not be accessible, and all these end users are kind of a downtime for them. It's a business downtime. That's the disadvantages with the standalone. When it comes to RAC, right, like users are connecting with the same thing, your mobile device or desktop device or the web URL, all will go to the same application server. From application server, we have server node 1, node 2, and node 3, different servers. This user will go to the server 1, this user will go to server 2, and this user will go to server 3, and all will be accessing the same database here, right? And then what happens here, if this particular server goes down, automatically this user connection will be passed to this existing instance here. And if this instance goes down, automatically this connection will go to here, and this connection also goes to here. Automatically, that is called a transparent application failure, right? That's called transparent application failure, TAF. We have again concept we're going to explain in part of actual course, but remember this is called TAF, transparent application failure. If any client connected to any one node, and if that node goes down, automatically his connection will be passed to any other existing node. That's called a TAF, transparent application failure. That's a beauty of RAC. So your end users will be continue to access your database even though one node goes down. We can call it as a server or node or a cluster node or anything. All are same. I can call it as a node sometime. I can call it as a server. I can call it as a cluster node, or I can say node 1, node 2, node 3. All are referred to your Linux server, right? That's a beauty of RAC. Once a node goes down, automatically connection will go to other node. There won't be any downtime at all here, right? And then when you are doing a patching, in order to patch your database, you have to bring down your instance. It's a complete downtime again, right? In case of RAC, when you're doing a patching of your database, you're going to shut down only instance 1. You will patch this one and you'll start this, and you'll go to node 2. You're going to shut down this one. You'll patch it and you'll bring it up. You're going to go to node 3. You will patch it and bring it up. It's a continuously rolling patching. So again, no downtime at all for that patching, right? So it's a highly scalable, lot of features with the RAC. That's the simple understanding how this RAC works. I'll just give a comparison between my RAC here. I'll just take one more session. Let's see. Do I have that one? Give me a second here. Database course. Okay, here. Right. I'm just going to connect. I'll just connect and then I'm going to drive through. Before that, I'll go to my paint here. Right. So let's go here. This is my standalone. This is my, I can say, Oracle Lab 1. And then this is my two node rack here. I'm going to drive here to node rack. Right. Right. So this is my rack and this is my standalone. I can say this is my I can say this is node 1 or server 1. These are your Linux server and this is your node 2. And in case of rack, what happens, right? You're going to run your database. I can say this is my DevDB. Right. So what I'm doing here, I'll just install my DB software U01 and 19C DB home _1. So I'll just install my 19C database software. Right. So this is my database software U01 19C DB home. I'll install this database software. On that database software, I'm going to create one database here. Right. And then all this database related files are on this particular server 1. Whatever this Oracle lab 1, everything will be on this lab 1. But whereas in case of rack, what happens? Instead of keeping all the database files in one server, I'm going to attach some disk here. Right, these are my disks. I'm going to attach the disk into my both the server. I'll attach this disk here and also at the same time to node 2. Again, this disk I'll attach here. I'll attach it here. And again, same thing. All the disk, whatever you are seeing here, I'm going to attach it to both the nodes. So that if anyone connected to node 1, they can able to see all this disk. Anyone connected to this node 2, able to see all this disk. So with that, I'm going to install the same software, database software on both the nodes. U01 19C DB _ DB home _1. So this is my database home. I'll install it on my node 1. At the same time, I'll install it on my node 2 as well. And then I'm going to create the same DevDB on this server here. I'm going to create DevDB here. The moment I create a DevDB here, and this database is visible on node 1 and same time it's visible on node 2. So what I'll do now, I'll just create database instance here. Like I can say this is one instance and this is my second instance. So this is my DevDB1 and then this is my DevDB2. Right. So if anyone connected, like, if I can say client 1 want to connect, he can connect to my node 1 and client 2 wants to connect, he can connect to my node 2. Right. And if he connect to client 1, connect to node 1, he will connect to this DevDB instance 1 and via that the database DevDB will be accessed here. And if client 2 connect to my node 2, that is my DevDB instance 2, via that DevDB instance 2, he can connect to my DevDB here. Right. So irrespective of clients can connect to any nodes, the instance will be running on that particular node. Via that instance, they can access my database. This database is stored under shared disks. These are your shared disks because these disks are shared between all the cluster nodes. Right. If this client connected to this node 1, if this node 1 goes down, and automatically this client will be connected to your node 2. That's a very, very brilliant feature in case of rack. But in case of standalone, if the client 1 connected to this Oracle Lab 1, he connected to this DevDB. And if this is a server, if server goes down and this client connection will be broken and there's a downtime for him. Right. So that's how your client connections plays very, very crucial, right? You have to be, your client connection should be served 24/7 without impacting them. So with the standalone, it's highly impossible, right? And with the rack, you can achieve it easily, 0 downtime. Right, I can quickly show that one. I connected to my Oracle Lab 1 here, right? And then I can log into my database server, DevDB, and SQL plus /SDBA. Right, I connected to my database, you can see it's just a DevDB. There is no 1 or 2, right? You can see here it will be DevDB 1 and then it will be DevDB 2. If it's a rack, it will be like this suffix will be attached 1, 2, which is standalone. There is no suffix, like just a DevDB. So here, if I do select name from $, data file, you can see all the data files, your system, sysocs, undo, user, all the data files are available locally on that host, right? If I can exit, if I can go to this location, user own app, Oracle, Data, data files, and LSF and LTR, all the data files are available locally on that server, on this server. If this server goes down, all these data files are inaccessible. Entire this database is inaccessible, right? Connect back again. Again, I'll run one more time, same command, select data files, right? So data files are all locally available. Select name from $, control file, right? All the control file, you can see control file 1, control file 2, both the control files again available on the locally on the disk. If that server goes down, control file will not be accessible. Select member from $, log file. All the log files, you can see all the log files also available locally on that particular host. Again, if that host goes down, nothing will be accessible, right? If this host goes down, nothing will be accessible. No redo log files, no control files, no data files. So your database is completely down. No users, no client or no end users are able to access it. Right? That is your standalone. If I can go to rack here, this is my node 1. You can see node 1 rack, right? Node 1. And then this is my node 2. If I do PSFNEF grep smon, I have my ASM2 running here. And again, I'm going to talk what is ASM and all as part of our regular class. And if I can go here, PSFNEF grep smon, you can see devdb1 instance 1 and devdb2 instance 2 is running here. And if I can connect to my devdb, I'm going to run this one .inv SQL plus /as/sysdba. Right. I'm going to run the same command, select name from $, data file. That you can see $, select name from $, data file. Everything start with a slash. Everything start with a slash means that's a local file system available on that server. And if I can go to my rack here, everything starts with a plus. Plus indicates these are your disk groups. These data disk group, right? These data disk group are made up of your disks here, right? This is my data disk group. I can say entire 1, 2, 3 combining. I can say plus data. So this combining this 1, this 2, this 3 all together, I can make it as a disk group called data disk group. So all my data files resides here. If I can see here, data, all my system, sysocs, undo, users, right? All the data files are available on the shared storage. If this instance 1, like this node 1, if this node 1 goes down, I have this node 2. My database can be served. If I can connect to this node 2 here, .inv, I can set this environment to .inv here, or at devdb2, SQL plus as sysdba. And again, I'm going to run the same command from the node 2, and I can see the same data files. Right? You can see same data files. That's a beauty of your rack. Your data is stored under shared disk. If any one node goes down, no worry, doesn't matter. You have other node to access your database, access your data files. Select name from $, control file. Right? You can see data and reco, control file 1 and control file 2. So if I run the same command on the node 2, I can see the same files. Select member from $, log files, right? All the log files, again, one is on data and one is on reco. Data, reco, data, reco, data, reco. All are available on the disk groups, shared disk groups, right? On both the nodes, you can see them. So that's a beauty. That's a use case of your rack. Why this TFA, transparent application failure, will be like able to achieve, because your data is under shared disk. Right, that's a importance about RAC, how like multiple or enterprise organization will go for RAC. Again, we're gonna talk more in detail about how we are gonna keep these data files and what are the files are going to be kept on my ASM disk group. And then if I do ps-ef grep smon, I can see devdb1 here and asm1 here. What is this asm1? Right, this asm1, and if I can go to node 2, if I do ps-ef grep smon, and I can see my devdb instance 2 is here. And what is this asm2? I can see asm1 is here and asm2 is here. What is this asm? Why, what's the use case of this ASM, and then how I'm able to form this cluster will be covered as part of the course. This ASM is a mean for forming this cluster. We're going to install something called Clusterware software, and then we're going to form this 2-node cluster here. If I can go to my standalone server here, I don't see any ASM over there. The test one, I don't see any ASM here. Like it's just a devdb and testdb, 2 databases we're running. Right. There's a question in the chat here. What is TAF? It's a called transparent application failure. Again, as I said, right? Your client is connected here. Your client 1 is connected to node 1. And then if this node 1 goes down, automatically this client connection will be failed over to your node 2 or node 3. That's called TFA, transparent application failure. Transparent application failure. This is the application your apps user, and then this apps user connected to, or end user connected to your node 1, and the node 1 goes down. Without noticing him, we are directly connect to any of the node 2. That's called transparent application failure. Right. So yeah, again, these are common questions in most of the interview. What is TFA? What is transparent application failure? And what is scan? What is VIP and all? Right. Yeah, this is what the typical setup here. And we can quickly talk about the some of the IP addresses. What that IP addresses and what are the IP addresses are needed, I can give you some idea. I'll just make it as a, this is node 1, and this is your node 2. And for node 1, you need a VIP. VIP stands for virtual IP, and you need a physical IP. And the same thing for node 2 also. Let's see, I can take it here down. Right. For node 1 and node 2. For node 1, first you need a VIP, and node 2 also you need a VIP. And for node 1, you need a physical IP. Node 2, you need a physical IP. That's a mandatory IPs you need. And on top of that, you need something called scan. Let's go here. You need scan. I can just type scan VIP. You need a scan VIP. And then you need 3 scan VIPs for any rack setup. Scan 1, scan 2, scan 3. You need a 3 scan IPs. So I can just give some dummy IPs. 192.168.1.100, and then physical IP here 101, and then VIP 102, and again VIP 103. Like you need a 4 IPs: physical IP, node 1 VIP, and node 2 VIP, and scan 1, scan 2, scan 3. 103, I can go with 104, 105, 106. Right. So these are minimum IPs I'm talking about when you are talking about setting up your Clusterware 2-node rack. I'm talking about 2-node rack. What are the minimum IPs are needed? And then private IP, and here just observe what I'm doing here. 192.168.2.100 and then 2.101. Right. So these are the minimum IPs you need it in case of building a 2-node rack. Right. Just observe what all you need to observe here. That's the second digit here. From the left side, this is first sequence, and this is second one. Like 192.168, 1 dot. Again, here also 1 dot. Here also 1 dot. Here also 1 dot. And these are like 1 dot. Right. These are like network 1. I can say IP range 1 or public IP range 1. Like 2 IP range. IP range 1 and then IP range 2. That we can typically call it as a different network. This is called network 1 and this is called network 2. So network 1, this network 1 is for this range of 192.168.1. This is one network range, one IP range, right? All this like VIP, physical IP, VIP, physical IP, and this scan 1, 2, 3, all are in this particular network, public network range. And then this one, private network, you can see this one, 192.168. This is a 2 dot series, right? So 192.168.2 dot. So this is your one more IP range 2. That's a network 2. And this network we can typically call it as a public network, and this network we can typically call it as a private network, right? We can call it as a public network and you can call it as a private network. What are the networks available in the rack? If someone asks, networks will be only 2. One is public and one is a private. And what are the IPs are associated to public network? Public network, I have VIPs, I have physical IPs, I have a scan IPs. These are the 3 IPs available in public network. And in private network, I have only private IP, right? So again, questions comes here. What are the different networks available in rack? 2 networks, public network and private network, right? Public network and private network. Public network is a one which end user can able to access it from anywhere, from the browser, from URL, or from any region or any country, anywhere he can able to access your servers. And private network, he will not be able to access your servers from outside your organization. He has to be in your organization network. He has to be in your VPN. Then only he can able to access. Otherwise, he will not be able to access. That's the name itself suggests. It's a private network. You should be on that particular your own domain in order to access those IPs. This public network, anywhere you can access, right? So those are 2 networks available in rack: public network and private network. And public network, again, they have a different IPs inside that. What are those IPs? Inside that, there are 3 types of IPs. One is the VIPs, one is the physical IPs, and others are your scan IPs. And in the public network, you need 1, 2, 3, 4, 5, 6, 7. You need a 7 IPs in public network, right? And then in private network, you need only 2, 1 and 2. 2 private IPs are needed for your private intercommunication, right?
Sir,
Mm-hmm.
for this private IP, you just change this domain like you made it 2.100. I think I read somewhere that the private IP, this total domain should be different. Like if public IPs are belong to 192.168, then this private IP should be totally different, like some random 162, 178.
Doesn't
Is
matter.
it like
No, you are going to be not in a different domain. It should be on a different subnet. Everything should be on the same domain. Like if your organization is wipro.com, all the IPs will be on that domain only. within that domain only, but it should be on different network. That's what I said, network 1 and network 2. Network 1 is for public network. Network 2 is your private network. Just you are changing that subnet mask here. This is called subnet mask. Just by changing that, you are able to do that private network. Right? Altogether, you need 9 IPs. In order to form 2-node cluster, you need 9 IPs. Right? Again, simple understanding, public network, private network. Private network is for only private node-to-node communication from this node to this node or this node to this node. It will not be accessible outside of your network, right? That's just for private communication. That's a private network. Public network, you can access it from anywhere. And what are the IPs comes in that public network? Your scan IPs, 3 scan IPs, and then your 2 IPs from node 1, 2 IPs from node 2. 2 IPs are like VIPs and physical IPs. Right. Now, question comes, what is physical IP and what is VIP? Physical IP is bound to that node, and physical IP again, that is bound to that node. If this node goes down, your physical IP will go down. And if this node goes down, your physical IP will be go down. Physical IP means the name itself suggests physically attached to that host. If that host goes down, your IP will go down. But your VIP will be like just floating under your clusterware. For example, your physical IP and then your VIP are like both are attached to each other. Right. And then any clients comes, like client 1 comes, he connect to this VIP. Via that VIP, he connect to node 1. And then once the moment your node 1 goes down, your physical IP will go down. And the physical IP goes down, and this particular client connection, which is connected to this VIP, it will be just floating under your cluster. And then that will be dynamically passed to your node 2. Your VIP will come here. Right. And then that's where you were able to achieve something called TAF, transparent application failure. Right. If that client is connected to this physical IP, and if this server goes down, physical IP will go down, client connection will be broken. Your client is always supposed to connect your VIP, that node 1 VIP. From that VIP, it has to connect to my server. So that when this node goes down, only your physical IP will go down. Your VIP, virtual IP, will be floating in your cluster. That VIP will be shifted to your node here. That's where now we're able to achieve something called transparent application failure. Right? So VIPs are not physical IPs. Those are like virtual IPs, not physically available. Those will be like virtually available, and those will never go down. Right? If node goes down, your physical IPs will go down. Your VIP will never go down. I can quickly show that in my lab here. One last demo, we can show it, and then ifconfig. Let's take here. Okay, this is my physical IP. I can take it here. Right, node 1, my physical IP. Node 2. Again, go to node 2, exit, ifconfig. Right, this is my physical IP. Right, so node 1, physical IP, node 2, physical IP. And for node 1, or else I can do cat etc hosts. I have everything here. Right, so node 1, node 2, public IP. Those are your physical IPs, 182 and 183. And then my VIPs here, virtual IPs for node 1. Sorry, what I can say, this is my physical IP. Sorry for the mess. Okay. Physical IP. Right. So node 1, node 2, my physical IP, and my next will be VIP. VIP. So this is my node 1 VIP. VIP. This is my node 2 VIP. Private IP. This is my private IP of node 1. And then same thing. Private IP of node 2 is 183. Right. So if you see 4.183, 4.191, 4.182, 4.190. So all are in 4A, right? This is your one network, subnet, we can call it as. All are on the same network. But private IP, you can see 9 dot. Right? Those will be in a different network. And my scan are here. I can put it here on the top, my scans. These are my 3 scans, right? Scan 1, scan 2, scan 3. Again, those are also on the same network. Right. IF config. So 192 you can see here. 192 is 192. Where is 192? Right, not this one. 191. I want this 190. Where is 190? Mm, 183, 192, 191, 183. Yeah, it's here. Right, 183 is here. Like 183. Okay, I'm on node 2. Sorry, my bad. Okay, here 190, 193, 194, and 182. So my 182 is my 182, and then VIP. Where is VIP? 9.182 private IP, 9.40. 1 second, guys. Where is 90? Okay, here. This is my node 1 VIP. You can see that, right? Your interface ENS 192, whatever the IP associated to that interface is called a physical IP. Right. So my 182, 4.182 is my physical IP. How I can get to know it's my physical IP? Whatever this interface, whatever the IP associated to that is called a physical IP. And all your VIPs will tag to that physical interface. You can see this is my VIP. It is just tagging to the same 192, 192:1. So if anyone you are going to see this one, the physical interface followed by colon and 1, that's called your virtual IP. If one single IP tagged to your one interface, that's called a physical IP. Right? This is called 182, and it just tagged to this interface 192. So this is, I can easily say this is my physical IP. And then how I can get my VIPs? So you can see :1, :3, :4. These are your virtual IP. These are all your VIPs. Right? And then out of that, you can see this is 192. 190 is your VIP of that node 1. 190 is a VIP of node 1. And what about these two, 193 and 194? Again, those are also VIPs are tagged to the same interface. Those are your scan, 193 and 94. These are your scan VIPs. Again, scan also VIP, right? So those also tagged to the same interface. Your VIPs will be tagged to the same interface, but the physical IP will be associated to one interface and then one physical IP. And since all are on the same network range, subnet range, so the same interface followed by your virtual LAN, virtual VLAN, we can say virtual LAN, it's going to connect to all the VIPs here. Right? If I shut down this node 1, all these VIPs will go to my node 2. Right? Node 2, I can see only one interface here, 192 and 191. And the moment I shut down this node 1 here, all the interface will move to my other node. I'll just go shut down my node 1, CRS-CTL stop CRS. Right? You can just observe here. Right, stopping is going to stop here and stop resource. Right, stopping your node 1 VIP. Like you can see here, start. Right, it's all running. Start node 1 VIP. Oh my God. Okay, it's all running. Let it complete. We'll talk on that. Right here, attempting to start node 1 VIP on node 2. Right, your node 1 VIP failed over to node 2. Any clients are connected to node 1 automatically will be passed over to node 2. That's your TFA. Right, let it complete. Right, your Clusterware is down on node 1. If I can go to node 2, and these are my IPs right now, you can see 183, 192, and 191. And then these are your 9 series is a private network. So in this 192, right, you can see 192 interface, I had only 1, 2, 3, only 3 IPs I had. Now if I run the same command ifconfig, and you can see here in this 192 interface series, now how many IPs? 1, 2, 3, 4, 5, 6 IPs. Right? What are those 6 IPs? In this particular node 2, now you have your physical IP and your node 1 VIP, 2 IPs, and then followed by your node 1 VIP, 3, and followed by your all 3 scan IPs, 3 plus 3, 6. All these VIPs are failed over to your node 2. That's called your transparent application failover. Any clients connected to your server, all will connect via VIPs, and your VIP will never go down. Right? So if I can go here on node 1, if I do ifconfig now, everything is gone now. Right? You can see, go down, sorry, node 1, right? Node 1, ifconfig. You can see you have only 4.192, only one IP on this node 1. Other IPs are gone now. Other IPs earlier, what all you have it? You had all these IPs. Your node 1 VIP, your scan VIPs. All these 3 IPs are failed over to your node 2 because your entire cluster is down on this node 1 here. Right. So that is a quick introduction on what are the different IPs, how this failover happens. And if somebody asked in any interview, what are the minimum IPs are needed for my 2-node rack setup, the answer should be, it's here. 3 for scan and 3 for node 1 and 3 for node 2. The scan, all are your scan IPs, your virtual IPs, your public IPs, sorry, physical IPs, all will be on the same network range. Like you can see 1.series, 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 and your private should be on a different network. So minimum we need 9 IPs in order to form a 2-node rack. If you want to add one more node, you want to add node 3, again you need 3 more IPs. Whatever these 3 IPs, the 3 IPs we need here: VIP, physical IP, and private IP. And now it become 9 plus 3, 12 IPs. Right? Yeah, there's a one more question in the chat here. What is the use of scan? Again, that's a different story. Why we need a scan? Your scan will be here. I'm just brief you, like your client 1 comes. Your client, how it's going to connect to node 1 or node 2? Who is going to drive that one? Your client is going to connect to scan. The scan will route it to node 1. And client 2 comes, connect to scan. The scan will route the connection to node 2. Again, client 3 comes, it will connect to scan. He'll going to route it to my node 1. Again, client 4 comes, he'll connect to scan. He will route it to node 2. The scan is kind of a load balancing. Equally, it will going to distribute the load between your cluster nodes. What happens if you don't have a scan? Like, client 1 comes and he will directly connect to node 1. Client 2 comes, he'll directly connect to node 2. Client 3 comes, he'll directly connect to node 3. Client 4 comes, he will directly connect to node 4. So you're just putting a load on node 1. You're not using node 2 at all. That's not an optimal use, right? So because of that, the scan is going to be very, very important. Your scan will come here, and then scan will route, okay, client 1, go to node 1. Client 2, go to node 2. Client 3, go to node 1. And client 4, go to node 2. Like scan is brilliant or intelligent enough to route this direction. Again, we'll discuss more on that, how it can be achieved, how the scan knows how much load are on my cluster nodes, how that scan balances the load and all. We'll understand more once we start the actual class. But the scan is for load balancing, simple understanding. Right. All right, guys, we'll stop it here for today. If you have any questions and queries, feel free to ask. Otherwise, we're good to
Malik. Malik.
Yep.
This is Sada again. I just missed one last part. You said we need for 2-node cluster, we need like 3, 4, 7, 9 IPs.
Right.
At one point, you said 12. Where is the remaining 3 going?
No, I said 12. If you add node 3, if you want to add node 3, you need
okay.
3 more IPs.
Okay, I got it. No.
All right. Again, like 1 second. Again, this 9 is the bare minimum IP needed. I can add 2 more IPs here. I can have something called here MGMT IP. MGMT IP. So these are like again extra 2 IPs I can add it here. But again, these are like not a mandatory. Mandatory is 9, what is must needed. I can have management IP. I can install my agent for EM communication, right? So those are like extra IP you can configure. You can customize.
Okay.
But yeah, that's a 9 is a minimum needed for any 2-node rack setup.
For 3-node, it is 12. That's what you say.
Right.
Okay.
And you can do customization. Like right now, for your scan, 3 is the minimum needed. You can add 2 more here, or you can add 3 more here. There's no limit for the scan.
But minimum is the 3.
Minimum is a 3, and minimum is a 3 for each node. So 9 is a bare minimum needed for 2-node rack.
So the scan 1, scan 2, scan 3, just to substitute the load balancer. If I have a load balancer, a separate hardware piece, then I don't need scan 1, scan 2, scan 3 for 2 nodes.
No, scan is a mandate. It's a part of your clusterware setup. Without scan,
Okay.
you cannot install your clusterware. That hardware
Okay.
load balancing is a different concept. At network level, you are doing it.
Okay.
Yeah. All right. Any questions, guys? Before we wind up.
Quick question.
Mhm.
Okay, when we use that 5 scan, like what is the requirement when we prefer to go with the 5 scans in a 2-node? Is it mandated? Is it needed?
No,
Will it help in any way?
3 scan is mandatory. You cannot go lesser than 3 scan. Your rack setup itself will fail if you specify only 2. 3 is the minimum needed. You have to configure 3. And it left to you whether you can go with 5, 6, 10, doesn't matter. There's no restriction at all.
So what is the advantage I get it if I add still 2 more IPs for the scan for a 2-node?
2-node, it's the 3 is minimum needed. There's no advantage. Like if you're going with the 8-node cluster or 16-node cluster, and then it makes sense. Like if you can go with 5-node or 7-node or 8 scan, then that makes sense. But 2-node, 3 is bare minimum needed. That's more than enough.
Okay, thank you.
Yeah. Again, like there's a different concept I'm gonna cover when it comes to scan. Why we need those many scans, right? I can say what I can say here. Let's go back here. I have my scan here. Scan. I can add 192.168.104. So I can run only scan with one IP. One client comes, this scan route here, and second client comes, the scan will route here, and third client comes, third client will gonna route here, fourth one comes, you're gonna write here. One scan, one IP is more than enough. But why we need a 3? Why we need a 5? Why we need 7? Why we need 9? Why we need like more scan IPs? Why we need that one? That's called client side load balancing. What is that client side load balancing? Client 1 comes and he will gonna connect to your scan. And if the scan is running with one IP, and if this IP is some reason due to network packet drop, this IP is not available. And then this client will be connection disconnected. It says, okay, while client is connecting, if the scan is busy and this IP is not available, and it says that, okay, connection will be broken and he has to reconnect again. And if you go with a 3 scan, the first client will try to connect to scan and the one IP is busy and automatically it's going to go to second IP. While second IP will connect to node 1. And if second IP is also busy, you're gonna go to third IP. From third IP, you're gonna connect to node 1. So that is called client-side load balancing. The scan, these IPs are just like, I can say, useless. With one scan IP, with one IP, I can run it. It'll absolutely run fine. But the point is why we need these many IPs. In case of due to some packet drop or this IP is not available, this client connection automatically pick up any new IP and then it's gonna connect to your existing node. That's called client-side load balancing. And there's a one more concept. After scan, take that client connection, you're going to intelligently route the connection to node 1 or node 2. That's called server-side load balancing. Actually, scan will do two tasks: client-side load balancing and server-side load balancing. So why these three IPs? That is because to provide this client-side load balancing. And scan default feature is server-side load balancing. Server side, it know how to load balance it. Right. Is that answers your questions? Or yeah, that's a built-in feature.
What does scan stands for?
Scan, okay. Single client access name.
Okay. Thanks.
Again, sorry, I can't remember. That's might be a single client access name, something. Yeah, I forgot.
Never mind.
Yeah. All right. Any questions, guys, before we wind up?
Can you show the scan IPs? Like you helped us to understand the physical IP which has been connected to the interface. Like how the scan you're assigning it.
It's not a scan IP, it's a scan VIP. Right? You can see scan VIP.
Yeah.
The moment VIP comes, it's the same, right? It'll be tagged to your physical IP, right? Your physical interface, physical IP. And for the same physical interface, your scan also will be attached here. These are your scans. 193, 194 are your scan. Where are those? 193, 194. Again, these are also VIPs. Those will be pegged here to your interface. Right? There's no separate interface for them because those are VIPs. Scan is also VIP. Node VIPs are also VIPs. Your VIPs will not be tagged to any physical interface. Those will be pegged to existing interface. So this is your existing interface. This is your public IP. And for this interface, you have your node VIP and also you have your scan VIPs. Like scan VIP 1 is here, scan VIP 2 is here, scan VIP 3 will be in your node 2. Like your scan will be distributed across your node 1 and 2. Like it's here. Scan is here. Scan 1 is here and scan 2 is here and scan 3 is here, right? To attach to the same public that interface.
Yeah.
All right, let's stop it here now. If no questions, we'll connect tomorrow we're going to cover some more Clusterware startup sequence and your ASM, how that file structure will be distributed. All those things we can discuss tomorrow. All right, guys.
Hello, sir. Hello.
Hello.
Yeah, I have one question.
Yeah.
So, if the in the server means more than one database is present, in that case also Clusterware will be the same, right? Same process.
Yeah, it's a one Clusterware. You can run multiple databases.
Okay, that all the process like CTSSD, CSSD, and all that it is not dependent on the number of databases.
No.
So if I want to just stop the cluster for only one database, that is not possible.
You can stop that one database, right? You can stop your one database.
One database, but for maintenance, like if I want to maintain something for the same server, more than one database is present, and that cluster patch or grid patch I want to apply, then I have to shut down all the cluster.
Yeah,
And,
if you want to patch your Clusterware,
the,
you have to shut down your entire cluster on node 1.
And all the database also.
All the database also should go down. The moment you shut down your Clusterware, all database will go down on that node.
Okay.
How this stack works, it will be like this. Node 1, node 2, like in simple understanding, it will be your ASM software. On top of that, On top of this one, you're going to install your Oracle Home. On top of that, you're going to install your Oracle Home, or else like you can take it here. So how this going to work here? Like your ASM, on top of that your Oracle Home, and then on top of that your database will be running. Same thing goes to your node 2 as well. ASM, and then your Oracle Home, and on top of that your database instance will be running. So if you want to patch this ASM home, the moment you shut down this ASM, underlining your Oracle Home and your database instance will be down here. And the moment you patch this one, the moment you shut down your ASM home here, underlining Oracle Home and Oracle database will be down here, right? And then you may having Oracle Home 2 here, and then database 2 here, and you may having your Oracle Home 3 and database 3. The moment you shut down your ASM, all will be down, right? That's your base. ASM is your base on that node. If you shut down your ASM here, automatically all database instance running on that node will be down. But you're not going touching anything on the node 1 if you're patching on node 2.
The ASM also should present only one in the server, right? Not more than one ASM will be present.
Only one ASM home, that's called grid home, and you have multiple Oracle home and multiple database instances. But your
in
ASM,
some server, I saw that ASM1, ASM2, ASM3 like that.
no, it's
present on
not
the
possible.
ASM2.
It's not possible. It should be one ASM at one server. You cannot run multiple ASM on the same server.
Okay.
All
So that
right.
is the naming. I think. Only ASM2 means only ASM2 will be present. It is there.
Sorry, ASM2 only means?
In some servers, I saw that ASM2 is there, not ASM. It's ASM2 or some ASM3, some naming convention they used.
They can give whatever naming convention, but how you can understand there should not be any plus here. They can use ASM1, ASM2, ASM3, ASM4. That is your, not a ASM, that's your database instance. But they cannot create a plus ASM. Plus ASM is for your actual ASM.
No, without plus, what is that?
Without plus, it's just your database instance, not a ASM instance. You can create your ASM instance 1, ASM instance 2, ASM instance 3. That's your database instance. The name you given that one, like that ASM. Right? You cannot create a plus ASM1 plus ASM2 plus ASM3. That's not supported. Right? How you can see your DevDB2 here, instead of DevDB, you can create ASM3 without plus. That's your database instance, but wrongly given as ASM. That's your mistake.
And if I do PS minus CF grep M1 or S1, that only the database that is like DB1 is running
Right.
in another server, it will not show here, right?
It will not show. Only that, but yeah, it will not show. Only for that DB related services it will not show.
But why it is showing that DevDB2, it should show that actual database name, that is DevDB.
Again, you're missing the basic, right? These are your not a database instances.
Okay,
you have instance 1 and instance 2. Database will be in your shared storage. I explained this one here, right? Yeah, this is your DevDB1 and DevDB2. That's the instances. Both are pointing to same database on your storage. All right, guys, let's stop it here now. We'll connect tomorrow. Thank you all.
Thanks, Malik.
So thank you, buddy.